People of the internet, welcome to Modern Day Debate. Tonight we are debating the Big Bang, and we are starting right now. I am Kaz, host of the Atheist Edge. Tonight we have Leo, Phileas, and Grayson teaming up against Rebekah and Sal. Each team is going to get 10 minutes for their opening statements to split between them. I believe that first we have the team Big Bang going first, and Grayson, you're going to be going first. So at your first word, I will start your timer. The floor is all yours.
Hey everyone, my name is Grayson from the new YouTube channel Based Theory. This is my first time on Modern Day Debate, so I just want to thank Kaz for hosting us tonight and James for arranging this debate. To quickly summarize the evidence for the Big Bang, because there's a lot of it. Number one, the correlation between redshift and distance, which is unexplainable by any alternative models. Number two, the solutions to Einstein's field equations, which show us that the universe is either expanding or contracting. Number three, the time dilation we observe in redshifted phenomenon, which shows us that space-time is what's expanding. Number four, the distribution of matter in the cosmic web. Number five, the abundance of light elements in ratios predicted by the Big Bang model. Number six, the spectra of the most distant galaxies showing more primordial chemical composition. Number seven, the cosmic microwave background, the CMB, which is definitive evidence that at one time the universe was so hot and dense that only plasma existed. There is no other physically plausible explanation for the CMB. Additionally, the temperature fluctuations observed in the CMB also exactly match the predicted peaks in the power spectrum of the lambda CDM model, which includes a verified dark matter peak. This is actually evidence not just of dark matter and the Big Bang, but the adiabatic nature of these fluctuations was predicted by the inflation model, and thus also serves as reified evidence for inflation as well. The temperature values resulting from these primordial oscillations also closely match the values of yet another prediction of the Big Bang model, one that seldom gets the attention it deserves: the neutrino background. Like the CMB, but with neutrinos instead of light. The Big Bang model predicted a temperature of 1.95 Kelvin for the measured value. Or the predicted value was 1.95, the measured value was 1.96. This is observationally verified evidence and precisely validated predictions of the Big Bang model. There are also observations of signatures from the very first stars during the so-called reionization epoch. These first stars would have been made of only hydrogen and helium, no heavier elements yet. And although the paper is still in peer review and not yet officially published, the preliminary results look like JWST may just have found these first stars, known as population 3 stars. The math tells us that they would have been much brighter than any stars today, which would explain why the earliest galaxies we see in the JWST are so bright. But beyond describing the elementary composition of these first stars, the models of early galaxy formation are not contained within the Big Bang model and are not within the purview of cosmology, but are a different field of science. Now, our opponents tonight are going to try to cast doubt that the redshift we observe is really from the expansion of spacetime. We know it can't be from these galaxies actually moving away from us, because that would mean that the most redshifted galaxies would be moving faster than the speed of light. The redshift also cannot be explained by plasma, because plasma redshifts light via scattering, which would necessarily blur the light, which we do not observe happening. Thus, the only model that can fit the observations is that the redshift is caused by the expansion of spacetime. Our opponents may bring up dark matter or dark energy, but even if we completely threw out the Big Bang model, we would still have evidence that dark matter and dark energy exist. Namely the rotation of galaxies that we observe right now today, as well as gravitational lensing and supernova observations. Beyond the observational evidence, we also have verified physics down to the first few millionths of a second after the Big Bang. In the late 70s and early 80s, it was predicted that at one point the energy density would become so high that even protons and neutrons would break down and a new kind of plasma would be formed, made of quarks and gluons. Several decades after this prediction, quark-gluon plasma was detected in particle accelerators. Thus, we have experimentally verified physics describing how you can shrink every galaxy, star, and planet into quark-gluon plasma in an area smaller than our solar system, just a few millionths of a second after the Big Bang. This is known as the quark epoch. I often hear incredulity when creationists talk about the Big Bang and how you can fit the whole universe down to the size of a purse or a period on a page, but this is verified proof that we have experimentally demonstrated the physics behind how that is possible, or at least very close to it. To get all the way down to the size of the singularity requires more advanced physics than we have consensus for at the moment. Most cosmologists would agree that the singularity is a mathematical construction, not an object that really physically exists. And we need new physics to be able to describe what is actually happening on that level. Thus, our current model of the Big Bang does not describe the nature of the singularity, what caused it, or what came before. That physics, namely quantum gravity, is not included in the model. But the preponderance of evidence that we do have clearly shows that the universe was once in a very hot, very dense state. So, Leo, I'll pass it on to you.
Yeah, thank you for that, Grayson. It's going to be hard to follow up with that. That was a very good outline of the evidence, I would say, that we have for the concordance model in cosmology, which I think that the first thing that I'd like to say is that the concordance model, or the standard model of cosmology, if you were to ask anybody in any department of physics and astronomy at any university around the world, they'd tell you it's an incomplete model, and all of them know that it is an incomplete model. So pointing out its incompleteness is not an objection to the parts of it that are established. I just want to make that clear. There are really only a couple of points that Grayson outlined that I'd like to try to go into more detail on. The first one is Einstein's field equations. There was a man named Alexander Friedmann who was capable of deriving exact solutions to these equations. These are these equations of general relativity that were first developed by Einstein et al. And his solutions were for the kind of space-time you would have if it were near uniformly filled with matter and radiation, much like our universe is. And what sort of fell out of the physics describing that, what fell out of the equations, is that regardless of whether it's expanding or contracting, that space-time cannot be static. Now, this led many physicists to believe it was probably contracting as a result of the mutual gravitational attraction of all of the matter and radiation in space-time. But it was later in the 1920s, with observations made by Edwin Hubble, that we knew that no, space-time is actually expanding. And the important point about that is that it's not just that the galaxies are redshifted, it's that the level at which we observe the redshift is mathematically proportionate to their distance. And as Grayson said, there are some of them that are so distant from us, if it were the actual galaxy moving, it would be violating everything we know about fundamental physics, the very foundation of modern physics as it stands today, because these objects would be moving faster than the speed of light. It isn't the objects that's moving, the space between us and the objects is growing. And to move on from that, the cosmic microwave background, which has been called the smoking gun, I would say that it is the effective proof. If you take proof in the sense that scientists mean it, not in the sense that mathematicians do, the cosmic microwave background is the effective proof that the Big Bang occurred. Because what the hot Big Bang model is, it doesn't describe an explosion. It doesn't tell us where the universe came from or how it got here. All it says, in summation really, is that the universe, very, very early in its history, was in a very, very hot and very, very dense state. And what would fall out of that would be, as Grayson said, that there would be a period where you wouldn't have stable neutral atoms. You would only have plasma. However, if the universe were expanding as a result of this hot Big Bang and the inflation that preceded it, what we would expect is that at some point in its future, it will have expanded and diluted its matter radiation to the point that it cools. And when it cools, all the electromagnetic radiation that was being scattered off of all the protons and the electrons that previously couldn't go anywhere, so to speak, will now be capable of free streaming through the vacuum of space. This would have occurred about 380,000 years after the Big Bang, and we should be able to detect that radiation today, and we do, and it is the cosmic microwave background. It is uniform and isotropic to 1 part in 100,000 everywhere we look in the sky, and anybody who has ever objected to it has to this day never brought a single model that can explain why we observe this kind of radiation other than the hot Big Bang model. And during this period, stable neutral atoms would have formed, and what they would have formed are the lightest elements on the periodic table, hydrogen and helium. The universe is today, in terms of its baryonic mass energy density, roughly 70% hydrogen. During this period, it would have been roughly roughly 75% hydrogen, 24% helium, and 1% other elements. And so the cosmic microwave background, and I'll finish with this, the cosmic microwave background tied with the abundance of the early elements both provide strong concordance with each other for the universe having originated in a very, very hot, very, very dense state.
All right, thank you so much, Leo. And now we will turn it over to the anti-Big Bang team for their 10-minute opening statements to split. I believe it's Rebekah going first. So, Rebekah, at your first word, I will start your timer. And let me put your screen on there. All right. At your first word, I'll start your timer. I think you're muted.
Hello, everyone. It's great to be here. Thanks for listening to this debate. The Big Bang Theory says that everything necessary to create all the billions upon billions of stars and galaxies emerged from something smaller than a pea. This is an extraordinary claim. We do not have extraordinary evidence to support this claim. In fact, the Big Bang has repeatedly failed to match up with our scientific observations, and most of its predictions have failed. The problem is, when scientific observations haven't matched up with the Big Bang model, instead of concluding that the theory might be wrong, hypothetical entities have been invented to salvage the theory. Now, nearly the entire edifice supporting the Big Bang is made of processes, energy, and stuff that we have not observed and cannot explain. For example, inflation. Sir Roger Penrose, Nobel Prize-winning physicist, calls inflation a fantasy. It's just something made up to get the universe to do what you want. For the current model of the Big Bang to be correct, 95% of the universe must be made of ghost matter and energy. Despite great effort, dark matter remains unobserved and unexplained. How about dark energy? Dark energy is a mysterious anti-gravity force, which supposedly kicked in a few billion years ago to help the universe expand faster. And at the very base of the edifice supporting the Big Bang is the idea that the universe is expanding. This is the essential pillar of the Big Bang. Michael Disney, an astrophysicist who's been skeptical of the Big Bang, said, if expansion were to fail, then so would the entire superstructure. Without expansion, there is no Big Bang. So what is the evidence for expansion? Leo likes to say that general relativity is evidence for expansion. Not true. Einstein thought the universe should be contracting because of gravity, not expanding. And evidence for our theories comes from our observations, not from other theories. Redshift is the main support for the idea that the universe is expanding. We observe that distant objects in the universe are redshifted, and the farther away they are, the more redshifted they appear. Redshift is observed, but expansion is not. Expansion is an interpretation of the redshift and a faulty one. Redshift has a correlation with distance, but there is no reason to interpret that correlation as space expanding. In fact, many of our observations with the Hubble telescope and now the James Webb telescope have provided excellent evidence that space is not expanding. This is an article from the journal Galaxies. The black dots on this chart are previously observed galaxies, and the red dots are galaxies we have observed with the JWST. If the universe is expanding, we would expect to see these galaxies plotted along this dotted line at the top. But the majority of galaxies have angular diameters that fall on the dotted line below, which is the non-expanding model of the universe. Spectroscopic analysis tells us that these galaxies have the same chemical content, number of stars, and type of stars as the galaxies in the local universe. But when we calculate in for expansion, these galaxies would have to be smaller, denser, and brighter than any galaxies we see in the local universe. Some would say impossibly small. The authors of this article conclude that the observations of these galaxies cannot be explained by the expanding universe model. Here's another paper that shows that galaxy data contradicts the expansion model. Galaxy observations provide strong evidence that the universe is not expanding. According to Big Bang predictions, those galaxies shouldn't be there at all. With the JWST, we are now observing distances that reach all the way back to 250 million years after the supposed Big Bang. We are observing fully formed spiral and elliptical galaxies, which, according to the model, are supposed to take billions of years to form. The Big Bang model also predicts that we would see many galaxy mergers, but we don't see the large number of galaxy mergers needed to create larger galaxies. Ivo Labbé, the lead author in a recently published study in Nature, saw the data from the JWST observations and said, "I nearly spit out my coffee. We just discovered the impossible, impossibly early, impossibly massive galaxies. Those galaxies are only impossible with the Big Bang." Joel Leah, co-author in the recent Nature article, said, "We are informally calling these objects universe breakers." Well, don't worry, guys. The universe is just fine, but the Big Bang is dead. Here's a list of scientists who agree. I turn it over to Sal.
All right, my screen is ready for sharing. Once upon a time, Thomas Henry Huxley, also known as Darwin's Bulldog, said, "The great tragedy of science, the slaying of a beautiful hypothesis by an ugly fact." For me, the beautiful hypothesis was the Big Bang Theory as articulated by Robert Jastro's book, God and the Astronomers. But over the years, ugly facts have emerged to slay the beautiful hypothesis of the Big Bang. While I was an undergrad at George Mason University, my textbooks taught me of the Big Bang, but there were three prominent physics professors there who openly objected to the Big Bang in what their fellow faculty members were teaching me. I went on to study physics in graduate school at Johns Hopkins University. During that time, Adam Rees, a professor at my school, won the Nobel Prize for his supposed discovery of the dark energy anti-gravity force of the Big Bang. Though I celebrated the fact that two professors in the same year from my school won Nobel Prizes in physics and in chemistry in 2011, I lamented that Rees's Nobel Prize might be in vain, since there were whispers among faculty and grad students at his own school and outcries in the scientific literature that his conclusions were disconcerting, to say the least. The Big Bang is predicated on the assumption that space is expanding, and this claim is further predicated on the assumption that galaxies are apparently moving away from us in all directions. But are the galaxies really moving away from us, or is this apparent motion an optical illusion created by the interstellar medium of free electron plasmas that are abundant in space? By way of analogy, here, for example, is an optical illusion of water, supposedly bending a pencil. But is the pencil really being bent by the water, or is the water merely causing an optical illusion of bending? So by way of analogy, can interstellar medium composed of sparse free electron plasmas create an optical illusion of motion? The answer is yes. But first, some basics. If I am speeding, a police officer with a radar gun that detects I'm speeding, he uses the gun to transmit a radar signal at one frequency. And then as the radar signal bounces off my car, the radar signal frequency is changed from high to low. And this change from high to low is called a redshift of the radar signal. The radar gun then uses the amount of change in frequency or redshift to compute my velocity. Now, ask yourself, if radar guns don't use expanding space model, the Big Bang, to compute relative velocity from redshifts, then why should astronomers? Should I say to the police officer, "But officer, I wasn't speeding, space was expanding"? I wouldn't say that, of course not. So even granting there is apparent relative velocity, why even assume expanding space is the cause of the redshift? One can just as well assume something is speeding through non-expanding space. But worse for the Big Bang space model, the redshift may not even indicate relative velocity because electromagnetic waves traveling through the abundant amounts of photoionized free electron plasmas in space can be shifted from high to low. This has been experimentally verified both in laboratories and spaceships flying through the solar system. Holy cow! Holy escargot Paderewski, the snail is moving close to the speed of light. Easy there, Robin. Since the snail is far, far away, the interstellar medium is confusing the radar gun. The snail is moving at a snail's pace. The radar gun is not accounting for the abundant interstellar free electron plasma. Therefore, the gun thinks the snails are moving almost at light speed. It's an illusion of speed. Check out these papers. In other words, shift happens. Shift happens, and that's why the Big Bang is a big blunder. And thank you, Kaz. Thank you, Grayson. Thank you, Rebecca. And thank you, Leo, for hosting this debate. Thank you.
All right. Let me just get that off the screen. And with that, ladies and gentlemen, that will be the end of our opening statements. We will be going into our round of rebuttal, cross exams, and open discussions. It's going to be a hodgepodge there in just a moment. But I just want to let you know, especially if it's your first time here joining us at Modern Day Debate, that we are a neutral platform hosting debates on science, religion, and politics. And we want you to feel welcome no matter what walk of life you're from. And if you have a question or a comment for one of tonight's debaters, please fire it into the old live chat and tag me at Modern Day Debate. Super chats will go to the top of the list. All that we ask is that you keep it civil and attack the argument, not the person. Insults will not be read. And I want to say thank you to the moderators in the chat for working tirelessly to elevate the conversation as well. Our guests are linked in the description below, whether you're listening on YouTube or via the podcast. We are on many different podcast platforms, so click the links if you like what you're hearing as soon as you can, and hit the subscribe button because we have plenty more live debates coming your way that you don't want to miss, including this, the 1st of March. We're going to have Dr. Ben Burgess versus Infrared, and they're going to be debating Trump communism on trial. And that's going to be at 8 p.m. Eastern. You don't want to miss that. And with that, we're going to go ahead and kick it into our discussion. We're going to go back to the Big Bang team. They're going to have the first 10 minutes to control. And I believe, how did you guys want to run this one as a open discussion?
Yeah, I think
I'm willing to let Grayson pick for this one.
Yeah, so I just wanted to point out, and I want to hear from the other side, but just really quick, in those openings, I want to point out that we didn't really hear anything other than what Leo and I brought up in our opening, like the redshift not being from expansion, which we clearly demonstrated has to be the case because these galaxies cannot be physically moving away faster than light. And the clarity of the pictures that we receive in telescopes show that this is not the result of redshift from plasmas. Plasmas redshift things by scattering them and blurring the image. The images that we see are clearly not blurred. Therefore, the redshift cannot be from movement of galaxies and cannot be just redshifted from plasma. We also talked about how the JWST data of galaxy formation doesn't really apply to the Big Bang model. It's a different area of science. It's not cosmology. So we addressed that as well. And then the only other thing I heard was quote mining from some innocent scientists that don't ultimately agree with the conclusions that you're trying to drive from their quotes. So before we let you guys address that, Leo, is there anything that you wanted to add on?
Yeah, there is. So the first thing I wanted to say is that I in fact, in my open, and this is specifically to Rebecca, I believe in my opening, I might be mistaken, but the playback, I guess, is where people are going to have to go. But I'm pretty sure that I had mentioned that physicists early on, after Friedman derived his solutions, believed that space-time was indeed contracting. Einstein did not like that. That's why he invented what we now know as the cosmological constant, and we still, in fact, use. This was a force that was exactly equal to that contracting force that would have pushed back outward, so to speak, and would have thereby kept space-time static. And it was only after Edwin Hubble confirmed his observations of galactic redshift, which I'll mention nextly, that Einstein abandoned that, claiming that it was the biggest blunder of his career. And with respect to redshift, like Grayson said, I don't know what a free electron plasma is. I have heard of a free electron gas, but again, that would scatter light, and the redshift signature isn't going to look like what we see. Because again, and this is something that I believe both me and Grayson mentioned in our opening statements, was that it isn't redshift simplicator that's important here. What's important is the redshift as a function of distance. That's what, not just that there's redshift that needs to be explained, but why the redshift is proportionate to the distance of the galaxies. The further away the galaxies are, the more redshifted they are. So those were just, and I think I would concur finally with Grayson that I didn't really hear anything that provides better explanations than what either me or Grayson outlined, which is still held by the consensus of cosmologists as the concordance model.
Well, Leo, first let me say I created that slide about general relativity because the last time we had a discussion on this, you emphatically asserted that general relativity is evidence, strong evidence for the Big Bang. So that is why I did that. And responding to Grayson about the redshift, we are not saying that the redshift is velocity. So there's no issue with things having to move past the speed of light, but actually your theory requires something to move past the speed of light because during the inflationary period, the universe expanded faster than the speed of light. Sal, do you have anything you want to respond?
Yes, there is. It's contested where there is time dilation, so redshift by plasma is possible. That's only one of the mechanisms. There is a lot of photonics research to resolve the blurring problem, so this could be gone. But the other thing is we actually have experiments that show how we can have redshifts. There is no experiment where we have expanding matter. It is only in the imagination of cosmologists. And so this is still an open issue. I don't think we're going to lose this issue. There is a lot of research on this. I'm really impressed. Photonics is moving forward. Now, galaxies moving faster than the speed of light, how can we possibly see them if they're moving faster than the speed of light? I would have to discount that totally and say, is that part of your model? If it is, then that's just circular reasoning because that is experimentally not verifiable as far as I know, that you're going to detect something moving faster than the speed of light. How are you going to do that? The redship's going to be just like off the charts. Yes. So, by the way, those are great points. You guys argue this well. I'm just a little, you could tell I'm passionate about this, but I salute you, gentlemen. You're really brilliant. And I think these are great things that you point out. I think I love the criticisms you put forward, but I think we've addressed it. We will also, in our 10-minute segment, put forward things that I think will start to answer some of your things, such as the supposed claim of time dilation in various things like supernova, quasars, and gamma ray bursts.
Okay, well, I look forward to that. I was just going to say, Leo, really quick, in terms of space-time expanding faster than light, this is not the same as saying an object is moving through the medium of space-time faster than light. These are substantively different things. No object, no bit of energy or mass can move through, or no bit of mass can move through a medium faster than light. But the space-time itself can expand in a metric scalar sense faster than light. There is nothing in the laws of physics that are prohibiting that from happening. So this is a misunderstanding that I often will hear. And then also, Sal, I heard you say photonics and just gesture broadly to some kind of advances in the field of photonics that somehow can explain why these redshifted things that we see in observations are not blurred as they would be in any kind of plasma scattering. But I didn't hear anything specifically other than just you saying that there are some kind of advances in photonics that can describe it. Leo, did you hear anything that you want to add?
Yeah, so with respect to the claim of inflation going faster than the speed of light, like you touched on there, Grayson, the speed of light, and this comes from Einstein's special theory of relativity, the speed of light is not a restriction that applies to space-time. Space-time is a manifold, and per general relativity, it can be stretched and contracted and twisted and warped and sheared and all sorts of things. And we as humans can and do interpret that as gravity. Just pick something up and let go of it, and you'll observe that. So the thing is, you cannot exceed the speed of light in space-time. It's not really something to do with light so much as it is to do with space-time. Space-time won't let anything go faster than light within it. But that doesn't mean that space-time can't expand at whatever speed it wants, because again, the expansion, even during inflation, isn't into anything. That's just not how this works. As Grayson mentioned, this is a metric expansion of the scale in space-time, and inflation was just a period where this was exponential. So that's the first thing. And the thing is, with respect to what Sal said, he's not wrong with what he's saying about electron gases, free electron gases, redshifting light. He's not wrong when he says that happens. Like, it does that. The question is, though, do we get similar signatures to what we see in galaxies? And I don't think that we do. And again, just to touch on it, because I think that it's the important point that needs to be stressed here. It's not just redshift simplicator that we look at when we're talking about redshift in galaxies. It's their redshift proportionate to their distance. That's how we know it isn't the galaxies actually physically moving away at the speed of light. It's that the distance between us and the galaxies with respect to the scale of space is growing under the expansion of space-time, which is in fact a part, I believe, of the metric tensor of general relativity, and something that needs to be factored in if you're working at those broad cosmological scales, as far as I'm aware.
Yeah, so ultimately, I don't think that so far we have heard anything that is either arguing against the evidences that we laid out in our openings. I mean, the exact verified predictions down to like a few fractions of a degree there with some of these predictions. We listed a lot of them in the opening. I haven't heard any rebuttals to that yet. I haven't heard any physically plausible mechanisms that have been able to describe the cosmic background or the redshift patterns that we see, especially the correlations in redshift, gesturing to this idea of plasmas existing in between galaxies or in between stars. I mean, if we do the calculations about what kind of densities these plasma would have to be at in order to account for the redshift observations that we have, I don't think that math would check out. I don't think that you'd be able to get the densities of plasma necessary to cause all the redshift that we see in our universe that we see today. I mean, we would know if there was all this plasma floating around our solar system, we would be able to see that it's there. And we just don't see that. We don't see any scattering effects. We don't see any absorption bands from any of this so-called interstellar plasma that's floating around, redshifting everything. So far, mechanistically, we haven't seen any plausible explanations to the contrary of the Big Bang.
Okay, so now we'll give it the time over to the anti-Big Bang team for your 10 minutes. How would you like to run it, as an open discussion or
rebuttal?
Rebuttal
okay.
with
Sal, you're going to share your slides?
Yes, I have this. I'm okay.
All right, I will start your timer at your first word.
Big Bang expanding space model fails angular diameter test. Angular diameter is kind of an easy concept. It's kind of a visual measure, apparent visual size. So the farther a basketball is from the observer, the smaller it will appear, and thus have a smaller angular diameter as represented by the pink theta symbol. So the basketball in Euclidean space will look smaller as it gets farther. Its angular diameter shrinks, as you could see. In contrast, the Big Bang model, as the object is further and further from us, its angular diameter doesn't shrink as fast, and in fact, will start to get bigger. And this is a well-known, this is from a video on angular turnaround, and that's kind of how the basketball might appear. That obviously corresponds to galaxies. And so if we had like a plain Euclidean model, the basketball would just look smaller and smaller the farther it is. In the Big Bang model, it starts to get, it doesn't get smaller and smaller, it gets bigger at some point after the angular turnaround. In the Euclidean plus some plasma correction, you get this. It's close to the plain Euclidean model. So now connecting the two graphs to the one that was earlier shown from a peer-reviewed paper, that's just showing the relationship. So let me just say the dots there, and especially like the dots with error bars that look like TIE fighters, you can see clearly that they are clustering around either the Euclidean or the what I call the shift happens model. It is not clustering around the Big Bang, particularly the red data points of angular diameter, just so far away from the Big Bang, Big Blunder, expanding space model. So I think shift happens. The Big Bang is wrong. Now, Edwin Hubble, he's called the father of expanding space. And it's my little joke here. The DNA tests are in. And Edwin Hubble, you are the father of the Big Bang. And Edwin Hubble says, that ain't my baby. It's someone else's. And this is confirmed, surprisingly, even in his own words, as in this Los Angeles Times, December 31st, 1941. He said, while expanding space cannot be abandoned, Dr. Hubble said, present evidence is against it. This leaves the redshift of light a complete mystery, which still greater telescopes may solve. That was 1941. In 2021, as I alluded to it, there are these papers. When stuff goes through a dense plasma, it's a good model. We can extrapolate it to very sparse plasmas out in space. So this was a landmark experiment. It really was in 1974 that it was first put forward. It's been pretty much ignored, but then revisited in the Journal of High Energy Physics, Gravitation, and Cosmology, July 2021. And so let me try to explain a little bit of this. We have the solar corona, as can be seen here when the moon is eclipsing. And so we have the Pioneer 6 space probe transmitting a radio signal through the sun's corona. It gets redshifted. And so this is what it said. The discovery made in the study on how and why the radio signal under particular physical mathematical conditions undergoes a redshift should not only be considered a local phenomenon on a solar scale, but also a cosmic phenomenon on a larger scale applicable to all stars and galaxies. It is exclusively dependent on the distance of the astronomical object, on the density and temperature of the electrons in the surrounding environment, and on the wavelength of the emitted signal. The Hubble constant represents, for the first time in history, a loss of energy as a function of the fundamental parameters as shown in the following formula. You just abandon kind of the Baroque units. You can still put this in Hubble's law. The Hubble relation holds. It also explains some of the kind of funny anomalies we have. And if you dig through the paper, you'll see it. It also talks about the Wigner condition, the Wigner electron crystal condition that could be satisfied. Wigner won the Nobel Prize in Physics. We have confirmed the existence of Wigner crystals for the first time, like in the last 1 or 2 years. It is possible then that light will not be blurred. And those are some of the advances. It's in this article. And, that's why I'm saying it's still up for grabs whether this can be solved. I think it's more promising than trying to solve expanding space. There are also observations of frequency shifts and spectral lines due source correlations. That's the Wolf shift. As I mentioned, even at my university, my undergrad university, Cicero Roy did not like the Big Bang. And he pointed out this phenomenon of a Wolf shift, which is different than the shift caused by Wigner crystals. Two stationary objects can look as if they have velocity between them. And so, again, the Big Bang is wrong because shift happens. And I hand it over to you, Rebekah. Thank you.
Yes, and I think it's important to note, and by the way, I need to share my screen, thank you, that Hubble is the one who discovered the linear relationship, the distance and redshift correspondent, and gave us the Hubble constant, but Hubble himself did not interpret that as expansion. And in fact, he called it apparent velocity because he left open the possibility. He believed that there had to be some other explanation, or he looked for another explanation for redshift. Just because we don't have an explanation for redshift completely, at least we have some observational evidence that Sal pointed out right now. We have some observational evidence that redshift is caused by other things, and we have zero observational evidence that redshift is caused by expansion. Zero. And not only is it unobserved, expansion leads us to ridiculous conclusions like dark energy. Here's how dark energy was born. In Sal's opening, he mentioned Adam Rees, who shared the Nobel Prize in Physics in 2011 for the discovery of the accelerating universe. He was doing great work with supernova observations, and I'm grateful for that work, but there was a problem. In his Nobel lecture explaining his discovery, Adam Rees said, "What I initially measured and wrote in my lab notebook in the fall of 1997 was stunning. The only way to match the change in expansion rate I was seeing was to allow the universe to have a negative mass." There was a problem with those calculations. His calculations demanded that the universe had a negative mass. Clearly, the universe doesn't have a negative mass. So something had to be wrong. What is wrong is that he didn't question the presupposition about the expansion of the universe that went into his calculations. He said, "Now my computer programs were telling me that only an imaginary negative mass could match the apparent acceleration and cause reverse attractive gravity." His data made no sense with the expanding universe model, but rather than question the model, he looked for a way to adjust his data with an anti-gravity force. Now, where did he find that anti-gravity force? Well, we have to go back in time to Einstein. When Einstein was working out relativity, his equations seemed to predict that the gravity of the universe would cause it to collapse in on itself. He felt the need to insert something to counteract gravity, so he invented the cosmological constant. But Einstein said that as long as that cosmological constant was around, he always had a bad conscience. He knew it was just something he invented. He eventually ditched it. But in 1998, when Adam Rees needed an anti-gravity force to cause the universe to accelerate, he resurrected the cosmological constant. So the cosmological constant, which is known as the worst theoretical prediction in the history of physics, is now part of the current Big Bang model. Why? Because the Big Bang model desperately requires it. And folks, this is how dark was born. Dark energy was invented to account for a ridiculous calculation with the expansion model. Without Big Bang expansion, we don't have to invent anti-gravity forces to account for our observations of the universe. Thank you.
Okay, so is it our turn with
All right.
10 minutes?
Oh, can
Sal,
we?
do you want to say anything?
Yeah, we were just breaking up. If you see me just shut off my camera, it's just to kind of help the bandwidth issues. I didn't have anything in particular. So
I have something to say, and this is in regards to the light scattering with the plasma. High angle scattering just acts as absorption and remission, no blurring. That occurs with small angle scattering.
Okay, so if I can just respond to some of those points there. Like we said in our intros, dark energy, I mean, even without the Big Bang model, throw away the Big Bang model, you'd still have to explain dark energy. Maybe a better term is just the innate curvature of space-time that we observe. I mean, that is what dark energy is explaining, is the curvature of space-time we observe. That's what Einstein was trying to explain by introducing the cosmological constant, which he said getting rid of the cosmological constant was the biggest mistake of his career, by the way. So adding that back, he agreed with in the end, and he was a proponent for the Big Bang theory. He tried to convince Edwin Hubble of what his own observations were showing. Edwin Hubble did not listen and was a steady state proponent. But I'll just say that the personal beliefs of the scientists that are making these discoveries are not really relevant to what their discoveries show. I mean, we don't discount Newtonian mechanics because Isaac Newton believed in alchemy, right? So regardless of what Hubble believed himself, his observations clearly show the Hubble parameter are evidence of expansion itself. So the expansion that we observe in supernovas is evidence for dark energy. And even without the Big Bang model, we would still have that evidence present. The last thing I'll just say is that both of you gave allusions to the vacuum catastrophe for the cosmological constant problem, saying, oh, this is the worst prediction in all of theoretical physics. But what was the physics model that was making that prediction? Was it the Big Bang? No, it wasn't. It was quantum mechanics, right? That was what messed up the prediction so bad, is not the Big Bang model. What's making the prediction of the vacuum catastrophe, which was using quantum mechanics to calculate the background vacuum energy of the universe. And then when that was observed, there was a huge difference in that. So that's quantum mechanics that made that prediction. It has nothing to do with the Big Bang. So Leo, I'll let you add a few points from there.
Yeah, sure. So the first thing I wanted to address is the angular test thing. Sal isn't wrong on anything that he said. He just left out one crucial detail, that he was working with the assumption that the universe is Euclidean. When you work in the FLRW, I think it is, Friedman, Lemaitre, Robertson, Walker metric for space-time. Space-time is non-Euclidean, and then you have to deal with a variety of things. You have to deal with the Hubble parameter. You have to deal with a variety of other things in cosmology in order to do those tests, and then it's just not an actual issue. So it's only an issue if you're treating space-time as Euclidean on the cosmological scale, and it's quite obvious for anybody who's taken a course in general relativity that the universe is not Euclidean on the cosmological scale. So that's not really an issue for the Big Bang model. The other thing I wanted to discuss quickly was the Pioneer redshift thing. So, and I actually went and found, and I'm looking at it now, the same paper that we saw in the screenshot, and it says here that the specific study is based on a calculated orbital model of the Earth and Pioneer 6 system made on a scale of 1 to 100,000 by a CAD on the new tired light theory adapted to the geometric and physical configuration of the topic and on a computational method. So this is assuming a new tired light model of cosmology, one that hasn't yet been meaningfully reproduced and is considered disputable amongst contemporary cosmologists. With respect to the negative mass and the dark energy thing, that's the other thing that I wanted to talk about. Whatever Rebekah mentioned is not where dark energy came from. Dark energy came initially from the observation of what are known as type 1a supernovae, and how the further back we look, type 1a supernovae look different than they should. And what can account for that difference and how they look. I can't remember what the specific detail about them is, but they look different. But what can account for that is that if the rate of the expansion of space has been subtly increasing over time, there's also another phenomenon known as weak lensing that we see at the cosmological scale. I think this is at the level of the galactic and the supergalactic scale, that if space-time is increasing in its expansion, then the structure of galaxies will change, and we've been capable of observing the change that would map to an increase in the expansion of spacetime. And this would change the way that these galactic clusters gravitationally lens light. I think that what happens is, like, galaxies or galaxy clusters get a little bit further apart, and this weakens the lensing, which is where weak lensing comes from. Don't quote me on that, because I might be misremembering. But dark energy, the phenomenon that we're associating the term dark energy to, I should say, has been directly observed. And as Grayson has pointed out at least 3 or 4 times already, its existence would persist even if you abandoned the Big Bang model, because its existence is not... I suppose it might have some bearing on the hot Big Bang model. It really hasn't yet, at least as far as my personal research has revealed. But it's really not an issue for the hot Big Bang model. So I have to be honest. I've heard some interesting arguments from our opponents tonight, but I can't say that I've heard anything that I would think would lead me or any professional cosmologist, for that matter, to abandon the concordance model. And it doesn't look like at any point in the future that the concordance model is going to be largely abandoned. And as I mentioned in my opening statement, the concordance model has problems. It's not a complete model. There are things we don't know. We do not know everything about how galaxies formed or when. We just don't. We're humans. We don't live for those periods of time. We don't know precisely when the first stars formed. There's a lot of things we don't know about the universe. I don't think that's profound at all. I think that it's the reason why cosmology is still a very much lively field. Any cosmologist, like I said, will tell you this model is an incomplete model. But that doesn't mean that there aren't areas of it where we know that these things are true. We've observed them. They concord very well with all of our other observations. It would be like claiming that all of general relativity must be wrong because black holes. Except no, it's just that the theory is incomplete, and we don't yet know how to extend it further into those domains to understand a little bit more about how the world works. That's all I have to say for now. Grayson?
Cool. Yeah, I would just add 2 main things. The one, I've seen a continuous conflation of models of early galaxy formation with models of the Big Bang and models of cosmology and where the universe came from. And these are not the same thing. So, I mean, in the graph, we showed expectations of the lambda CDM model for the types of sizes of galaxies that we would see. So that's a little bit of conflating two things that really shouldn't be conflated. Our models of galaxy formation are different than our models of the Big Bang. And a conflation between the two really shouldn't be made, because our degrees of confidence in our models of galaxy formations are considerably less than our degrees of confidence in like the cosmic microwave background data, or like these quark gluon plasma physics. I mean, our evidences for the Big Bang have a much stronger degree of confidence than our models of how early galaxy formed. So what these JWST data is showing is that clearly these galaxies formed faster than we thought. I mean, we're going to have to come up with models explaining how early galaxies could have formed so quickly, but that doesn't really have much of an impact on the Big Bang model. I would need to see some more reasoning as to why we should throw out one because of the other. It doesn't really make a lot of sense to me. And then the other thing I noticed Sal saying that we could look at observations for these more dense plasmas in the coronas of stars, and we could extrapolate to how that would affect less dense plasmas, which my only question is, less dense plasmas? If a plasma becomes less dense, it stops being a plasma. It cools down and forms atoms, right? You only have plasma at high densities. That's how it works. You increase the density of matter and it will become plasma. The electrons will break of their atomic orbitals and you'll just have nuclei and electrons streaming around. That's what a plasma is. So it doesn't make sense to me to say, oh, that the universe or a solar system is surrounded by a very a plasma that's not very dense, but is dense enough to cause all the redshift that we see. That doesn't make any sense to me, and I haven't seen any mathematical models showing how that would even be physically possible. So yeah, I just want to see more of like alternatives, because all the alternative explanations I've seen so far for redshift are not really physically tenable. I haven't seen any alternatives for an explanation for the cosmic microwave background, which, as Leo pointed out, is one of the best proofs of the Big Bang, at least that the universe was in a hot, dense state that was all plasma, no stars in the past. I mean, we look up and we see that. So I need to see the alternative explanations for these things that actually make sense with known physics.
All right, thank you so much. And we will go ahead and kick it over to the anti-Big Bang team for their next 10-minute rebuttal section. So at your first word, I will restart your timer.
Can you share my screen, please?
Absolutely.
Thank you. And I just hope everyone in the audience will notice that although these guys have repeatedly asserted about the expansion of the universe, they have not given us one piece of evidence for the expansion of the universe. Leo mentioned supernova data, which this is looking at the Hubble constant. Yes, we're very happy we have supernova data to help us, and it's looking at the Hubble constant. This is the whole argument that that's being made here, is that the Hubble constant does not equal the rate of expansion, but they keep wanting to reassert that expansion is embedded in this relationship with redshift and distance. However, it has been known since the time of Hubble and continues to be known that there is a linear relationship between redshift and distance. You guys haven't given us anything about expansion. Now, let's talk. And by the way, with Adam Rees, you mentioned his calculations. Look what he says about, this is his calculation. This is from his Nobel lecture again. He talks about making a K correction. He says the reason he has to make a K correction in his calculations is because besides causing redshift, cosmic expansion also dilates time intervals over which supernova light is collected, changes the size of increments in brightness, and shifts the portion of the spectrum we observe. So it's his own calculations for accommodating expansion that caused him to get the negative mass that led to dark energy. Now, let's talk more about the Big Bang failed predictions. We've already talked a bit about the failed predictions about galaxy formation. Read more about that. You can look at this Nature article. There's this article, Panic at the Disc, that talks about the failed predictions with mergers. But these guys seem to think that just because they seem to think they can excuse themselves from having a model of galaxy formation in the Big Bang model. Galaxy formation is part of the Big Bang model. But even if we just say galaxy formation isn't part of the Big Bang model, okay, that still doesn't help you, because if you look at what we're saying about our galaxy observations with the JWST, it's not just about the time of forming galaxies. It's about what we are seeing in the galaxies themselves. They contradict the known sizes and brightness predictions for the expansion universe. You guys can read more about that in this article or in the other article that we presented the chart for. I think that that's actually showing that expansion is not true. Okay, so the problem with galaxies is not just about the time of formation or the lack of being able to create larger galaxies through mergers. It's that the galaxies themselves are impossible with the expansion model. Now, but let's go on to other failed predictions. How about the failed prediction about large-scale structures? In 1988, Joseph Silk, a prominent astrophysicist, said, if one measured a gradient or large void that extended over 1,000 parsecs, then I think he or she would have to seriously question the Big Bang Theory. But we're a long way off from anyone ever claiming that sort of structure. There are only small-scale structures. Well, guess what? That was 1988. And since then, we've found structures that exceed the size limit allowed for in the Big Bang model. For example, the giant GRB ring, 1,720 megaparsecs across, was discovered in 2015. And here's what this paper says about it. Recent discoveries of the structures exceeding the transition scale of 370 megaparsecs pose a challenge to the cosmological principle. So not only is this structure too large to form in the time that we have for the Big Bang, it also violates the cosmological principle, which is the idea that the universe is homogeneous and isotropic when viewed from a large enough scale. And by the way, general relativity only predicts expansion and contraction if the universe is completely homogeneous, and there is evidence that it is not homogeneous at any scales. Other large-scale structures which exceed the limits for the Big Bang are the huge Lazar-Quasar group and the giant arc. The existence of these structures contradicts the Big Bang model. How about lithium abundance? Here's a chart showing prediction for lithium in red lines at the top. And the actual observations of the lithium are far below the predictions. The Big Bang has many other failed predictions, and you can find this chart in the article by Eric Lerner showing the references for the predictions and the observations that contradict them. Over to you, Sal.
You muted, Sal.
Well,
Maybe to turn off your camera. You're muted. You need to turn off your camera.
Yeah, epilepsy warning there.
Yeah, that had them vibes.
Can you give me a few more seconds there, Kaz?
Yeah,
Thanks.
1 second. Let me fix that timer for you.
Yeah, this is why I've been turning off my camera. I've been here the whole time, guys. I wasn't playing hooky.
Okay. That's your first word. I'll start a 5-minute timer for you.
Stayed up.
Okay, I'll start a 5-minute timer for you at your first word.
Big Bang expanding space model may have failed time dilation tests of relativity. I'm acquainted with relativity. My first assignment in grad school was to go from Maxwell's equations and Michelson-Morley and derive special relativity from electromagnetic theory. That's just showing off a little bit what I had to do to derive special relativity. So there's general relativity and some aspects of that. One thing that is very important in the Big Bang model is that things that are far away, things should look in slow motion as pictured here. And one of those is gamma ray bursts. So gamma ray bursts at high Z, at a high redshift, should be slow motion. And we don't see that. What we do see is there's no slow motion, or what we would call time dilation. It is demonstrated in this graph by David Crawford. You could see the data points there of the length, the duration of these gamma ray bursts. And at high, as we get higher redshift, you should start to see it, those dots kind of cluster around the red line. It is not there. It's a failed prediction. However, the prediction of non-expanding space looks like it aligns with the data. This is controversial. Some people disagree and dispute this, but there it is. David Crawford, March 15, 2022, his latest revision to that article. And he said, Einstein's theory of relativity is quite definite that if the universe is expanding, then the observed duration of these measures will increase with redshift. An analysis of gamma ray burst data shows that the hypothesis of time dilation is rejected. And he says this is consistent with static space. Now with supernova, it's supposed to be the same thing. They have claimed that they have established time dilation. Crawford reanalyzed it, found that there was circular reasoning and inadvertent cherry picking. I'm not accusing anyone of deliberate deception here, but this is raw supernova data. Clearly, if it's expanding, it should be clustering around that line that says expanding as we go up in redshift. It is not. It is centered around the line of no time dilation. And now if we wanted to, let me just see, he says here, since time dilation is the main defining characteristic of an expanding universe, that is, that the redshift indicates expansion, the conclusion is that the universe does not show standard time dilation, and these results are consistent with a static universe. And, if one wanted to cherry pick, this is how you do it. You pick the data points that are along that red line. And Crawford pointed out that there was some degree of circular reasoning in those papers that included, sadly, Saul Perlmutter, who had a Nobel Prize along with Adam Rees. So I'm just going to, this has to be resolved one way or the other. I'm just throwing it out there. I'm not saying it's not a done deal that we have time dilation confirming redshifts indicate expanding space. Also, time dilation, the lack thereof in quasars. The main result of this paper is that quasar-like curves do not show the effects of time dilation. And then the author said, there is, however, a surprisingly little direct evidence the universe is expanding. Now, I'll talk about the cosmic microwave background radiation. Dr. Richard Liu, Distinguished Professor of Physics and Astronomy. He has lots of papers. Doesn't believe in the Big Bang or something modified. I don't know. Now, regarding the cosmic microwave background radiation, he said, well, the prediction by Gamow was off by an order of magnitude. Where do you draw the line? How would you like the temperature of your room to increase tenfold? There's also the problem with the axis of evil in that cosmic microwave background. It says there's an apparent correlation between the plane of the solar system and aspects of the cosmic microwave background. Lawrence Krauss, commenting on this, said the new results are either telling us that all science is wrong, or we're the center of the universe, or maybe data is simply incorrect, or maybe it's telling us something weird about the microwave background results, that maybe there's something wrong with our theories on larger scales. He wouldn't put the Big Bang in that category. There is the absence of gravitational lensing in cosmic microwave background. That is another failed prediction. As far as I could tell, this was a paper a long time ago. I know some people are looking into it. So that's just an open issue. I'm just throwing it on the table. I would like to salute my opponents. They are very fine gentlemen and very well educated. Thank you very much for engaging us tonight.
All right. So with that, we will go ahead and move into the Q&A section, I believe. Everybody got their two rounds, right? Is that right? Right. Nobody has an closing statement. Okay. So yeah, let me put 30 minutes on the clock, and then I will go into my list of questions for you guys. And then we will go ahead and get started with that.
Do you think, would it be possible if we could do closings, just because there was a lot of new material that was just presented in that last 10-minute section that Leo and I won't get the opportunity to address otherwise. So
I concord with that. I concord with that, but only if our opponents do. But obviously they would also have the final word with their final, say 3 to 5 minutes somewhere in there. But that's, again, if they're not okay with that, then I guess if Grayson kind of wants to go to bat for that, but I'll let.
I'm fine with whatever Kaz says.
Yeah, Kaz.
Okay, then how long are we saying? 2-3 minutes or 5 minutes?
2 minutes is fine.
Yeah,
2
I don't
minutes?
think I need a
Okay,
full
2
5
minutes.
minutes. So I just wanted to
Yeah.
address some of the points that were brought up because there were a lot of like new points that were just brought up in that 10 minutes. So, Kaz, can I start?
Okay.
So,
yeah, sure. 2 minutes on the clock. Wait, go ahead.
So yeah, Rebekah brought up lithium abundances and saying, "Oh, that's a failed prediction," but she ignores the fact that 4 out of the 5 lightest abundances were successful predictions. Lithium is the only one of those 5 that was not successful, and she's also ignoring the fact that there are numerous other explanations for why that amount of lithium might be different that don't involve errors in the Big Bang model, because we don't even know all of the different pathways that lithium is processed within stars. So there's a lot that we don't know about lithium chemistry that would come into play here and would be able to explain its current abundance without throwing away the entire Big Bang model. It doesn't invalidate the model. I would also say that for a lot of these most distant galaxies that she's pointing out in the JWST that are very small and very bright, we don't even know if these are actually galaxies. I feel like that should be pointed out. These are not very clear images at this point. A lot of this data hasn't even been published, and spectra have not been done on these to confirm that they're actually galaxies. She said that the spectra is that of modern galaxies, which is not true. The most distant galaxies have primordial spectra of mainly hydrogen and helium and different abundances than more modern population 2 galaxies, or population 1 galaxies rather. And then so we don't know we're looking at galaxies. For all we know, these could just be supermassive black holes in the early universe, or different types of stars. And we don't know enough to be able to conclude the kinds of things that our opponents are concluding about this new JWST project. The last thing I have time to bring up is the axis of evil in the CMB that Sal brought up, which, by the way, there is no consensus on whether or not this is even observed in the first place. Some evidence suggests it, and some evidence suggests otherwise. When we take a look at the totality of the evidence, we don't even know whether or not this axis of evil even exists. Much less, I mean, we have good observations for the other anisotropies in the CMB, and they all concord with the predictions of the Big Bang model and inflation and lambda CDM and everything else. So I'll leave it at that.
All right, Leo, let's start your timer at your first word.
Okay, so the first thing I want to address is that a lot of what Rebekah brought up was, again, galactic formation. That only I've noticed that her and Sal have brought up a lot of things, particularly with respect to this galactic formation, that are like tangentially related to the Big Bang, but us being wrong about how galaxies form or about how early does not defeat the fact that the universe was very, very early in its history in a very hot and very dense state. And it doesn't seem like either of you two have at least thus far disagreed with that or provided anything that seems to suggest that that wasn't the case. With respect to the time dilation in supernovae and gamma ray bursts, the work that was done by David Crawford has not been reproduced. I mean, I just Googled it quickly to confirm, and all I can find are, I think, 1 or 2 papers in Cornell University's archive, but I can't find anything confirming this. What I did find was a paper from April of 2005 called A Definitive Measurement of Time Dilation in the Spectral Evolution of the Moderate Redshift Type 1a Supernovae, with some prominent names on it, such as Alex Filipenko and this S. Perlmutter. I believe that's Sean Perlmutter, who both are prominent astronomers. So, I mean, not that name means anything, but prominent astronomers aren't likely to attach their name to work that's like disreputable or anything like that. So that's just not something that I think is enough to really meaningfully challenge the concordance model of cosmology. And then the final thing that I'll say is with respect to the axis of evil quickly, that's only measured in 2 different pole measurements of the CMB, the quadrupole and the octopole. There are at least 1,400 different pole measurements that you can do. So the fact that they arise in 2 is not meaningful at all. This is not even on the radar of cosmologists. It's a non-issue. So I'll leave it there.
All right, and then we'll kick it over to Rebekah or Sal for their 2 minutes. I'll start the timer at your first word.
Can you share my screen, please?
Certainly.
Thank you. So just wanted to put this one up really quick. This is from a paper in the monthly notices of Royal Astronomical Society. Since the linear hypothesis fits the supernova and local universe distance redshift data, it can be considered as a phenomenological hypothesis. And at this time, no physical model is proposed to explain the linear relation. We do not, the model that we are proposing of the non-expanding model, it matches also with the supernova data. So I just wanted to quickly say that. I also wanted to say that there is an alternative explanation for CMB. And I'm reading from Eric Lerner's paper here. It says that the CMB does not require a Big Bang. It has been noted repeatedly in the past and pointed out again that the energy needed to account for the microwave background radiation is comparable to the energy that would have been released by the production of ordinary stars of the known amount of helium as presented by Goal. And continuing on, the present author proposed that CMB is a radio fog permeating the present day universe, not some ghost of a long ago Big Bang. Also from Eric Lerner he says dilute plasma is the main constituent of our universe, the universe that we observe. The argument that dilute plasma can't be hot is nonsense. And continuing on, you mentioned that these galaxies and the spectroscopic analysis has not been done. That is flatly false. This is a published article in Galaxies. It's peer reviewed, and it is explaining what the data that we showed. Now, we have presented that all of these hypothetical entities make up the Big Bang Theory. We've attacked this expansion. You have not given us a thing for expansion. None of this exists. The Big Bang is false. It's dead. Thank you.
Thank you, Rebecca. And now, Sal, at your first word, I will start your timer.
I'd like to share my screen.
Certainly.
And I really want to thank you, especially since we're the ones who've been using the screen. All right, I'll start. The great tragedy of science is the slaying of a beautiful hypothesis by an ugly fact, maybe a single ugly fact. We put so many on the table. And just because the Big Bang is our best model, supposedly, therefore we should keep holding on to it. This is like putting we grab some random guy and accuse him of murder, and we'll keep him there until we find another suspect. That just doesn't make sense. Now let me just point some other things out. Another Michael Disney, respected astronomer. He said, another failure here. Tolman calculated the surface brightness, the apparent brightness per unit area of receding galaxies should fall off in a particularly dramatic way with redshift. So dramatically, in fact, that those of us building the first cameras for the Hubble Space Telescope in the 1980s were told by cosmologists not to worry about distant galaxies because we simply wouldn't see them. Imagine our surprise, therefore, when every deep field Hubble image turned out to have hundreds of apparently distant galaxies scattered all over it. The omens do not necessarily look good for the Tolman test at high redshift. If expansion were to fail, then so would the entire superstructure of the Big Bang. That was Michael Disney in 2007. Sorry for the date. And this is before JWST. This was very prophetic, and this problem continues. We have problems in inflation, and let's see, I had an Isaac Newton quote. I'm sorry, I don't have it. So that's all I have to say. I would like to congratulate our opponents for their very good discussion, and I salute you for the great arguments you've made. And thank you, Rebecca, and thank you, Kaz.
All right. Thank you so much, Sal. I appreciate it. And now we're going to go ahead and move on to the Q&A section for 30 minutes, which I believe is 1,800 seconds, but I guess we'll see in a second. Yep, that works. So we'll go ahead and start the timer now, and we will start answering the questions. I want to let everybody know that I don't have a huge list of questions right now, so if you have a question for any of tonight's debaters, fire into the live chat, and I will put that at the top of the bottom of the list, or bottom of the top of the list. Anyways, first question comes in from Thunderstorm for $4.99. Thank you so much, Thunderstorm. They ask, hi, I follow more of a third option since science can't explain the creation of Big Bang, that energy could be a deity, including the Big Bang itself. Because that doesn't everybody, so
that doesn't make any sense, I guess.
Who's that a question for?
I guess it's for everybody, or an observation, a comment. You can all say something about it.
Oh, well, thank you for the super chat. And it's great people have ideas. I don't have any thoughts on that. I'm sorry.
Like I was saying, it's a little weird to me. A lot of people ask, "Oh, what caused the Big Bang? What came before the Big Bang?" Inflation did. The hot Big Bang is the reheating period that immediately preceded the inflationary epoch. That's what it is. Unfortunately, we didn't get much into inflation in this discussion, but it's one that's often overlooked. But it is something interesting to get into.
Yeah, I mean, I guess if you want to worship energy as a deity, that's not really any skin off my bones. I mean, I don't think that, as long as you're not misconstruing scientific evidence or misrepresenting scientific theories, you do you. Think whatever you want to think about energy or deities or whatever. And small plug, I actually just made a whole video about what actually is energy. So maybe that person could check it out before the next time they pray to their little energy god or whatever.
Go subscribe to Grayson.
Well, right, yeah. I mean, hey, it's possible that energy could be a deity. I mean, it's equally possible. It just seems just as plausible as the Big Bang to me. So when we're talking about having beliefs and myths, Big Bang has just completely been in the realm of myth and dogma. So that's it.
Okay, I'm sorry. I got another question to copy over real quick. And let me just do that. And the next question comes in from Stay Curious for $2. Thank you so much, Stay Curious. They say, does she, I believe that's you, Rebekah, know about the Hubble constant?
Yes, I do know about the Hubble constant, and there's something really terrible that's going on right now in recent years in cosmology, and that is the conflation of the expansion rate with the Hubble constant. The Hubble constant is something that's well established. It's the relationship between the redshift and distance, and now it's being co-opted to describe the expansion of the universe, but there's no evidence that the Hubble constant corresponds to expansion.
Can I comment on that quickly? Because that was pretty much entirely incorrect with respect to contemporary cosmology. I think Rebekah is referring to the difference in the measurement of the Hubble parameter, where when we use, oh God, I'm going to butcher this because my memory just doesn't want to work right now. When we look at the CMB, we measure it to be, I want to say it's like 67 kilometers per second per megaparsec. And then when we utilize what are called standard candles, it comes out to, I want to say it's like 72 or 73 kilometers per second per megaparsec. And cosmologists do not know why these two measurements disagree. They shouldn't disagree, but they do. And that's fine because we're humans and we don't know everything. It does nothing to defeat the glaring, evident, and immediately demonstrable fact that the universe very early in its history was in a very hot and very dense state.
Yeah, and I just want to point out really quick that those two different measures of determining the expansion rate of the universe that Leo and Rebekah were pointing out, those only differ from each other by 10%, less than 10%. So yes, they differ from each other, but they're still within the range of being 10% accurate of each other. So that's not bad. I really don't think that this is some big crisis or whatever. I mean, two measurements that agree with each other within 10%, that's pretty close.
I will say at the cosmological scale, this actually is quite a. And when you look at it in terms of states, like 5 or 6 standard deviations away. So statistically, it is actually quite a lot. Cosmologists would consider that to be actually quite a large discrepancy.
If I may,
so let's let Rebekah and Sal quickly have a pithy response, and then we'll move on to the next question. Go ahead, guys.
Rebekah knows what the Hubble constant is. We've covered it. I helped teach her about it, and she's taught me a lot of other things. The Hubble constant is the redshift distance relationship. You can actually see it right there in the Hubble law. There's nothing about expansion. They do use speed of light in there, but when you divide the kilometers per second It divides out by part of the Hubble constant, which is in kilometers per second per megaparsec. Then all you end up with is something in the denominator that says per megaparsec. So it is not necessarily a measure of expansion. It is that's Hubble's law. It is a distance redshift. It's being extended beyond that. And we put that newspaper article where he said it doesn't look like it's expanding. I mean, I don't know how much more clear that is. He doesn't think even his own Hubble law indicates it's expanding. So yes, we are deviating from contemporary cosmology, but this is what this debate is all about. The contemporary cosmology is wrong. So Rebekah knows what the Hubble constant is. And I appreciated her explanation. That was the best explanation I've heard, because that conflation continues. That shows she has a lot of insight into this. And that was a subtlety that even I didn't realize until she brought it up and said, Sal, can you look into this? So I credit her with that. So thank you for the question in the super chat.
Yeah, when I put up the thing about the crisis in cosmology and showed the different things, I wasn't even trying to argue about the crisis in cosmology. I don't care about the crisis in cosmology because the CMB calculations are based on dark energy and matter and all the hypotheticals that you guys invented. So the supernova data is calculating the Hubble constant. And what I was trying to say is that you guys are conflating the Hubble constant, and it's saying that that's showing the expansion rate of the universe, but it is not.
Yes, it is, literally.
Okay, let's move on, shall we? All right, next question comes in from Mr. Monster, who is a member for 13 months. Thank you so much, Mr. Monster. They ask, what's a better explanation for the beginning? This is for you guys, the anti-bang.
I'd say maybe it's okay not to have one. I don't have specifics. Just like that whole thing with the, like I said, do we keep someone, under arrest until we find another suspect? That's just ridiculous. I think it's better to say, when we don't know something, just leave it at that until we have more data. And, Sherlock Holmes says it's a capital mistake to start theorizing in the absence of data. We have an abundance of speculations in the absence of data. And thank you very much for your membership and your question.
All right. Is that okay? We move on?
Oh, do you want me to answer too or no?
I would like to give you the opportunity, but if you don't like to, then
sure. Well, what I want to say is I also don't know, but there are some very good scientists who don't believe in the Big Bang, who have alternative models, but those models don't get funding. The Big Bang gets all the funding. And so how would we even discover a different model if none of those possibilities ever receive funding for research? Thank you.
And if I may just add, people know I have a personal belief about the beginning, but that's a faith belief. It's outside of science. So I don't have anything that I would classify as science. I just wanted to clarify that. So I do have personal things if you're willing to explore religious, but as far as science, I'm not ready to put anything forward. So I just wanted to clarify that in case people say, they hear, because we were advertised as creationists, but we're trying to talk a science debate here.
Yeah, can I comment on how
we'll have to give them the last word?
What's that?
Okay, but they'll have to get the last word. But okay, go ahead.
No, that's fine. I just wanted to say that I think that an actual cosmologist would probably say, with respect to that question, that we don't really know even if the universe has a beginning, or if that's a meaningful question to ask. There are quite a few cosmologists who would say that it's probably not the case that the universe has a beginning, or not in any sense we would understand the word. But we just don't know. We do know that the universe was very early in its history in a hot and dense state, and that it evolved from that. Why it did so, why this was such a low entropy state, these are questions cosmologists do not have answers to at the time.
Yeah, that's exactly the point I wanted to state, was that the Big Bang model does not necessitate that the universe had a beginning. Nothing about the Big Bang model says that this was the beginning of the universe. It just shows that previously the universe was in a hot, dense state. But it doesn't say anything about this is the beginning of the universe. The Big Bang shows the beginning of the universe. That's not a part of the model. So just thought that point should be emphasized.
Well, guys, I'm a little bit older than both of you. And what you're doing, this is revisionist history. This is gaslighting, because I was taught that this was the origin of the universe. And so now, because that's completely inconvenient for your scientific theory, now we're inventing, well, no, it wasn't the beginning. No, we're not saying anything about the origin of the universe. Okay, thank you.
It never did.
I do have to let them have the last word. So,
Well, yeah, we're not responsible for how you were taught the Big Bang by your teachers. So I don't know if they were not astrophysicists that were teaching you, then maybe that would be on them.
Well, go back and look at the history, guys.
Okay, so let's move on. Next question comes in from Big Bad Mama. For $5, they ask, Sal, the Big Bang predicts the observed abundances of primordial hydrogen, deuterium, helium, and lithium. Does your model?
I said I don't have a specific scientific model.
Got it.
Oh, by the way,
next question.
Big Bag Mana, very nice to hear from you, and thank you. She and I have met on the internet. We've had cordial exchanges. That was actually a pretty good question. So, there are a lot of things I don't know. But thank you.
Okay, next question comes in from Sunflower for $10. They ask, for Leo and Grayson, if you have no issue accepting dark matter / energy as a theoretical anti-gravity force, why do you have an issue with the theoretical particle or force that makes things go faster than light?
It seems like an incoherent question. I don't know what he's referring to.
With respect to dark matter is not an anti-gravitational force. Dark matter is an anomaly that is observed in the anomalies in our predictions of the differential rotation of galaxies from the centers to their outer edges. They should slow. The rotation should slow from the center to the outer edge, and it does not slow by nearly the amount predicted by baryonic matter that is present, the matter that we can see that's present in the galaxy. They should be flinging themselves apart. They're not. Also, there are galaxies that lens light, that gravitationally lens light significantly more than they should, given just a baryonic matter that's there. And also, there are galactic clusters that have gas in them that are colliding. And the interesting thing is that the dark matter in these collisions, if it exists, and if it is particle dark matter, not just modified gravity, then it should act independently of the baryonic matter that's there, at least for the most part. And that's exactly what we observe, because what we observe when these massive galactic clusters collide is that all the gas starts to accumulate at the center, but all the baryonic matter, all the galaxies aren't there yet. So why is all the gas there? Because gas usually follows whatever has the most gravity. That's because the dark matter, acting in a secular way to the baryonic matter, is moving through as these clusters collide, whereas the baryonic matter is reacting to the shocking and slowing of all of that gas. And this is one of the other things, is that modified gravity can't explain this, but particle dark matter can. So we observed that. So I just don't understand what he's talking about. With respect to the speed of light, that has to do with restrictions in space-time. The reason you can't exceed the speed of light in space-time is because if you try to do that, what happens when you reach the speed of light is lengths in the direction of your travel contract to zero, and your clock does not tick. And what that means is that once you've reached the speed of light, there is no more space-time for you to go faster into. So how do you exceed the speed of light? So that's why I'm not going to say that anything can, or I'm going to say that nothing can exceed the speed of light. How does it do that? And then, yeah, dark matter is just not an anti-gravity force.
Really, really quickly, I just want to tack on something really quick, is that our opponents and this question seem to imply that somehow dark matter or dark energy is this kind of like wacky, like ad hoc belief. But as we've pointed out, the evidences in support of dark matter and dark energy are independent of the Big Bang and would still be evidence even without the Big Bang. There are evidences to, like, reasons to conclude that dark matter and dark energy exist, and verified predictions is supporting them. And I'll just say that our opponents during the course of this debate, in their attempt at coming up with an alternative for the Big Bang, have variously proposed some sort of low density plasma hanging out around the universe, redshifting things. I even heard electron crystals were floating around in space that were redshifting things in a way that isn't scattering light. I mean, these are the things that are a lot more wacky and ad hoc sounding to me than the things that have evidence to support them independent of the Big Bang. So that's just my 2 cents.
All right. Thank you guys.
Can I respond to this?
If you do, then I have to let them respond too, and we'll have to go all the way around again. And can we just? We have more questions.
I think can I respond to the question that the audience member asked about dark matter?
Go ahead. I'll have to let them have the last word, but go ahead.
Okay. So what you'll notice is missing from Grayson and Leo's explanation of dark matter is what dark matter is. The world's most sensitive dark matter detector has found no signs of dark matter. We don't know what it is. This is circular reasoning. Hey, we've got a galaxy problem. The solution is dark matter. How do you know dark matter exists? Because without it, we'd have a galaxy problem. Obviously, but there's no difference, guys, in what you're saying than if I said fairies are holding the galaxies in place. If I said it was dark fairies instead of dark matter, how would you falsify that? The answer is you could not falsify that. And neither can we falsify dark matter, which means it's not scientific. It's a hypothetical entity made up to solve a problem. You can't use both the problem. You cannot use it as both the problem cannot also be the evidence for your hypothesis. Thank you.
I'd like to respond to that because this fairy thinks, yes, we can falsify that. So what's one reason why there would not be a differential slowing in the rate of rotation of galaxies as you move from the center outward? Well, and if there were extra, or rather, why don't galaxies fling themselves apart when they lack that? Well, an extra mass, extra gravity could explain it. Why did they gravitationally lens light more than what we see with just a baryonic matter? Well, if there are some other type of matter there that just doesn't interact with light, that would explain that. Why is it that when galactic clusters collide, the gas follows not the baryonic matter, but some other is following the fairies? No, it's following some sort of gravitational anomaly. So that's how we can falsify fairies, because fairies don't explain things and gravity does, and gravity can be utilized as an explanation for these things.
Yeah. So
and that's why we think it's matter. I just wanted to tack that on at the end.
We really must move on.
Exactly what Leo is saying. There are multiple lines of evidences for dark matter. It's not like we just have one circular line looking at galaxy spin. We also have gravitational lensing. We also have, like, when galaxies collide and those effects that we see there predicted by a particular dark matter theory. We also have, and just I pointed this out in my opening, but like fairies don't make mathematical predictions. We have mathematical predictions, like I pointed out with the power spectrum for the temperature fluctuations of the cosmic microwave background. It forms these various peaks, and we predicted that if 84% of the matter was dark matter in the universe, then the peak would be of this height. And then when we measure it in the cosmic microwave background, the power spectrum matches our prediction based on cold dark matter. So there are multiple lines of independent streams of evidence that corroborate each other. It's not just like one little circular line of reasoning. That's a mischaracterization of the evidence.
And most of them support particle dark matter over modified gravity. That's all I want to say.
Oh. All right, we have less than 2 minutes for each question now left, so we must allow only the person who's being addressed to answer specifically from now on, guys. From Claptripism, for $10, they ask, my hamster, George Hametre, is squeaking annoying about science fiction. George Hametre wants to know, what came first, the chicken or the egg, and how? Question for both sides.
The egg.
Neither.
Excellent.
Scientifically, I would say the chicken, and also religiously.
You need both, Rebekah? The chicken and the egg at the exact same time, and that's a problem.
The answer is obviously the lizard.
The answer is neither.
From Samir Farsain for $5, they say, anyone excited about CMB as evidence and about its correlation Did you know the temperature difference between colors is 1/200 millionth of a degree?
Wait, what? The difference in temperature in the CMB is a difference of about 1 in 100,000. It's near uniform and isotropic no matter how you look, or no matter how far out you look, and it's about 2.73 Kelvin.
All right. Next question comes in from Nix for $10. Thank you, Nix. They ask, it seems that the anti-Big Bang wants to debunk the Big Bang and science, but if it's wrong, what do you believe is correct, and what is the evidence for your belief besides God did it?
Can you repeat the question? I'm sorry. Thank you for the super chat.
Sure. They say it seems that the anti-Big Bang team wants to debunk the Big Bang and science, but if it's wrong, what do you believe is correct, and what is the evidence for your belief besides God did it?
No, we emphasize the scientific method. However, we don't think. I personally believe there's some things that are outside of science that explain the physical universe. The universe does operate by laws. I actually think the Big Bang is positively anti-science. It is lots of circular reasoning, things that are put forward as theories and hypotheticals are treated on the level of experimental evidence. I find that problematic. I've given lots of experimental evidences here for changes in redshift. Even Leo conceded it. So this is not about us being anti-science. I resist that. I kind of resent it because I have 5 science degrees. I am not anti-science. I'm for science. I think the Big Bang is very anti-science. It should go in the religion department because of its lack of experimental verification. Put it there. Let it be a hypothesis. Thank you.
I just want to clarify what I
Thank you so
conceded.
much.
10 seconds. 10 seconds, literally. I conceded that there's redshift, but I pointed out that it's redshift as a function of distance with galaxies. So I conceded there's redshift. I just wanted to clarify that.
Sal,
Rebecca,
I
you
will
have 10 seconds?
pray to the Big Bang that it will show you the light.
Guys, I really can't. We have to move on from the questions. We have too many questions on the list. Rebecca, final word?
Oh, no, go ahead.
Okay. We also want to shout out to 33% Done, who just became a member of the Extra Juicy Club. So thank you so much, 33% Done. Shout out to you. Then question from Stay Curious for $5. They say, science doesn't use newspaper articles. That's not the scientific method. So that's a comment for the anti-Big Bang team, I believe.
Thank you for that. That was a quote from Edwin Hubble, and he actually justified it in his book, which I credit Rebekah for finding. So no, science isn't done by newspaper articles. I didn't mean to imply that at all, but maybe I quoted the newspaper article because it's accessible to hear. He simply said in his own words that he didn't think the evidence was in favor of expanding space.
Yeah, it's in his book.
Okay, question from T.S. Apostolos for $5. They say, we are in a Copernican revolution too, so we forgive y'all. Ad hoc mathematical physics, just like the first. There will be a paradigm shift, a la Thomas Kuhn.
Is that for us?
I'm not sure.
Because I've read Thomas Kuhn's The Structure of Scientific Revolutions. I think it's all right, but I'm not really a Kuhnian with respect to my philosophy of science. I'm a Lacatosian, or at least I lean toward Lacatosian, more of a Lacatosian framework. I think there's going to be a paradigm shift, but it's not like we're going to somehow figure out that, hey, everything isn't actually made of atoms. That's not how science works.
Got it. Okay, question from Michael Thompson for $5. They say, does the Bible inform your understanding of the universe? Anti-Big Bang team.
It does. It does on a religious basis. It does. It does. Now, I try to separate the two and just, I'm more able to believe the Bible as I see the physical evidence supports it, but there's a lot of stuff that is just by faith. And I will just say, incidentally, I think a lot of the Big Bang is accepted on faith. I really don't see a lot of science. I see that because I'm a religious person, I see the same level of religious commitment to the Big Bang that I do in other religions. That's just my opinion. But yes, the Bible does inform my understanding, and I believe it. And thank you very much for asking and giving me the chance to confess that.
Yes, and I believe in the beginning, God created the heavens and the earth. So yes, the Bible does inform my understanding, but this is a scientific debate. And so I'm separating my religious beliefs from what were our physical observations of the universe. So this was a debate about the science or lack of it with the Big Bang.
All right, got it. 2 more questions on the list, guys. From Thunderstorm for $4.99, they say, in the corner of the universe, there are different kinds of energy of life. One of them is immortality, and its origin is beyond man. I believe that's for the Big Bang team.
I didn't know the universe had corners.
That's it? Okay, great. From Stay Curious, it's the last super chat, guys. If you have a super chat, we might be able to get it in. From Stay Curious for $5, they say, does Rebekah not understand that there have been multiple theoretical models in history and that we've been simply following the most verifiable data?
Yes, and I appreciate that when bad ideas can be overturned with our scientific observations. And I hope that will happen right now with the Big Bang, with the observations that have come out, which have completely destroyed this model as it was already weak. And now it has been completely obliterated by our observations. So I hope that scientists will be faithful to the scientific method. And I hope that they will admit and that their model needs a complete revision, probably to the degree of being completely thrown out.
All right. From Andrew Cumming, question for Sal. If redshift were caused by matter interactions in a plasma, why do we see a uniform shift across all wavelengths? Matter never does that.
Thank you for the super chat. That's a very good question. And that is one reason I've actually started looking to see if you get to see it across all wavelengths. There's only one paper that I see that has done that. It is a question worth revisiting. A lot of the instrumentation that does redshift is only in a limited band. And so they're going to assume it. So we really, I think it's an open question. Some people have been throwing it out. And could you repeat the question? I would like to honor that. Thank you for that question.
If redshift were caused by matter interactions in a plasma, why do we see a uniform shift across all wavelengths? Matter never does that.
We don't know. That's why I said we have to look into photonics. There are people that are working on this problem. And I would bet we're going to have, because we can experiment with photons and plasmas, even in the laboratory, we have a lot better chance of solving that because we can't have expanding space in our laboratory. So I would take that bet over something we have no chance of verifying, and we have no chance of verifying the inflation field directly either, where we would have expanding space moving faster than the speed of light. So I didn't really directly answer your question, but I know Andrew Cumming loves the Big Bang, and that looks like, I find that more problematic, that you're straining at gnats and letting camels through. Thank you.
We do know it's the expansion of space.
Yeah, that observation.
Last question for Big Bang team. The Big Bang team, they want to know, can you demonstrate one specimen of half one creature and half another? A dog will always birth a dog. A human births humans. Where is one birthing another?
Well, I'd like to say that, I've never seen a dog turn into a mosquito, and I've never seen an elephant turn into a pine tree, and I just think evolution is absolutely the most ridiculous idea I've ever heard of.
And I will just conclude by saying, your mother.
All right. Well,
come on down to Dal today. We totally don't diddle little kids.
Okay,
yeah, well,
question from
on
Tim
on the concept that the Big Bang is just a faith position, by the way, I feel like it's funny that our opponents ignored all of the very precise quantitative predictions that I went through in the power spectra and the neutrino background. None of that is faith-based. Those were mathematical.
May I respond?
Yeah.
One ugly fact.
Let's just get this last question.
Hypothesis. The geocentric model had lots of predictions fulfilled. It's the anomalies that broke it. That's what we tried to put forward today. That was the thing.
And the
we
ugly
put several evidences that break it.
And the ugly fact that redshift is not quantized and is continuous debunks all of these alternatives to redshift. So thank you for that. That the ugly fact exists. Therefore, the redshift is from expansion because it's continuous, not quantized, like we would see if this was the result of matter redshifting this light. Thank you.
All right.
Einstein
So,
said one experiment can falsify a theory. So Einstein said it too. So thank you.
all right. Are we ready to wrap it up then? Thank you all so much for being here. I really appreciate it. You, the debaters, are the lifeblood of the show, so we appreciate all of you. I want everybody to know that they're linked in the description below. So if you liked what you heard from any of our guests tonight, please feel free. Please, we encourage you to go and click on their links below. I want to thank again the moderators in the chat for keeping the conversation civil. You guys were working tirelessly, and we really appreciate it. Thank you to James for creating this platform, and everybody in the audience who sent in chats and questions and just enjoyed the debate in general. Once again, like it if you loved it, share it if you want to spread it, and subscribe. We have many more debates coming your way that you don't want to miss. Remember, on the first 8 p.m., it's going to be Dr. Burgess versus Infrared MAGA debate. So come check that out. Thank you, everyone. Once again, thank you, everybody, once again. Y'all have a great night. And remember to keep sifting out the reasonable from the unreasonable. Have a great night.